I am Caesar the Circlet, here talking to you about circles and circumference. Circles good, humans bad.
First vocabulary term is a circle. That's the set of all points equidistant from a given point called the center. So in our example down here, we have circle G, and it's denoted by this symbol right here. Now, a circle, again, is the set of all points along this blue region right here that are equidistant from this point in the middle, point G, that we call our center. Now, the second vocabulary term is a diameter. That's a segment that contains the center of the circle and has both endpoints on the circle. So in our example down here, notice that segment AD passes through the center of the circle, point G, and it has both endpoints on the circle. Point A is on the circle and point D is on the circle. Therefore, segment AD would be considered a diameter of circle G. Next vocabulary term is a radius. That is a segment that has one endpoint at the center and the other endpoint on the circle. So in our example down here, we actually have 3 examples of radii. Remember, a radius is just a segment that has one endpoint at the center and the other endpoint on the circle. So segment GE has one endpoint at the center, point G, and one endpoint on the circle, point E. Segment GD, even though it's part of the diameter, segment GD would still be considered a radius because it has one endpoint at the center of the circle and one endpoint on the circle. Segment GA would also be considered a radius because it has one endpoint at the center of the circle and one endpoint on the circle. Next vocabulary term is a chord. That would be a segment whose endpoints are on the circle. So in our example down here, you could see that we have segment BF as a chord because both endpoints, point B and point F, are on the circle. Same thing with segment ED or DE. That would be considered a chord because both endpoints, point D and point E, lie on the circle. Also important to note that you could technically consider a diameter to be a chord. So if we were to draw a segment connecting point B and point D that passed through the center of our circle, point G, that would be considered both a chord and a diameter. Now let's talk about the circumference of a circle. So that's one of the main things we're talking about today. The circumference of a circle is the perimeter of the circle. And the way you find the perimeter of the circumference of a circle, is you use this formula, pi times d. Pi times the diameter of the circle. So if we're looking at this example right here, if we wanted to find the circumference of circle G, the perimeter of circle G, the length of one revolution all the way around circle G, what we would do is we would take pi and multiply it by the diameter, the length of the diameter, which would be the measure of segment AD here. Now it's also important to note that the circumference can be calculated another way with this formula. The circumference is equal to 2 pi r. Now where does this come from? Well, it's the exact same thing as this circumference formula, only instead of using the diameter, we're using 2 times a radius. And that's because a diameter is just made up of 2 radii. So if I take a radius and multiply it by 2, I should get a diameter. So if you want to find the circumference of a circle, you can either use the formula circumference is equal to pi times the diameter of the circle, or circumference is equal to 2 times pi times the radius of the circle. Both of those will get you the circumference of your circle. Now let's talk about right triangles inscribed in a circle. So if a triangle is inscribed in a circle where one side is the diameter, then the triangle is right and the diameter is the hypotenuse. So all this is saying is that if you inscribe a triangle in a circle, meaning each of the vertices lie on the circle, and one of the sides of your triangle is the diameter of the circle, then that triangle has to be a right triangle. So in this example right here, triangle ABD is inscribed in circle G, and we know that because each of the vertices lie on circle G. We also know that one of the sides, segment AD, is the diameter of the circle, meaning triangle ABD must be a right triangle. Same thing here. Triangle KLJ is inscribed in circle M, and we know that because all of the vertices lie on circle M, and one of the sides of triangle KLJ is a diameter of circle M. Because of that, we know triangle KLJ must be a right triangle. Same thing up here. Triangle XYZ is inscribed in circle W. We know that because each of the vertices lie on circle W. Also, one of the sides of triangle XYZ is a diameter of circle W. Because of that, we know that triangle XYZ must be a right triangle.
Take the monkey off your back. It's example time.
Now example 1 says answer the following questions regarding the figure below. So part A says name the circle. So if we look at our figure over here, we see that the center point is called point G, meaning that this circle must be called circle G. You could also denote that with the circle symbol that we talked about earlier. Part B says identify a chord. Remember, a chord is a segment with both endpoints on the circle. So segment GA would not be considered a chord because one of the endpoints is not on the circle. It's at the center of the circle. Same thing with segment GB. Same thing with segment GC. Same thing with segment GD. But what about segment CD? Yeah, segment CD is a segment where both endpoints are on the circle. Therefore, segment CD would be considered a chord of circle G. Also, we have a diameter here, segment BD. Because segment BD passes through the center of the circle, that would make it a diameter. But it also has both endpoints on the circle, making it a chord as well. So those would be your two chords. Part C says identify a diameter. Well, we already did, remember? When we talked about a chord that passed through the center of the circle, that would be segment BD. And because that appears to be the only chord that passes through the center of the circle, that would be your only diameter here. Now part D says identify a radius. Remember, a radius is a segment where one endpoint is on the circle and one endpoint is at the center of the circle. So circle G over here has several different radii. Segment AG would be considered a radius because one endpoint is on the circle, one endpoint is at the center of the circle. Same thing with segment BG. Same thing with segment CG. Same thing with segment DG. Those would all be considered radii of circle G.
Ooh, ah! You tried!
Part 8 says name the circle. So here we have our center point called point R. Therefore, this circle would be called circle R. You could also denote that with our circle symbol. Next, we want to identify a chord. Remember, a chord is a segment where both endpoints lie on the circle. So in this particular instance, there are two chords we see here. Segment LQ would be considered a chord because both endpoints lie on the circle. Segment NQ would also be considered a chord because both endpoints lie on the circle. Moreover, for segment NQ, it passes through the center of the circle, point R. Therefore, a chord that passes through the center of the circle must be considered a diameter of circle R over here. Lastly, we want to identify a radius. Remember, a radius is a segment where one endpoint is on the circle and one endpoint is at the center of the circle. So segment MR would be considered a radius because point M is on the circle and point R is the center of the circle. Same thing with segment NR. Same thing with segment PR. And same thing with segment QR. Those would all be considered radii of circle R. Now example 2 says circle J has a radius of 8 centimeters, circle K has a radius of 6 centimeters, and the measure of segment BC is 3.2 centimeters. Find each measure. So part A, we are finding the measure of segment CK. So where is segment CK? That would be this little segment right here. Now in each of these types of questions, the very first thing you should do is label your figures. So here it says circle J has a radius of 8 centimeters. So this would be circle J right here, and if we know it has a radius of 8 centimeters, that means we know the measure of segment AJ over here must be 8 centimeters. Next, it says circle K has a radius of 6 centimeters. So because we know circle K right here is a radius of 6 centimeters, we know this measure right here, the measure of segment DK right here, has to be 6 centimeters. Lastly, we know the measure of segment BC is 3.2 centimeters, so the measure of segment BC right here must be 3.2 centimeters. Now we can get to answering our question. What is the measure of segment CK? So segment CK is right here. How would we figure out what the measure of this little segment is right here? Well, if we know that the radius of circle K has to be 6 centimeters, that means we know that the measure of segment BK right here has to be 6 centimeters. So if I want to find the measure of segment CK, I can just take the measure of segment BK and subtract the measure of segment BC. That should leave me with the measure of segment CK. So again, what's the measure of segment BK? That's 6 centimeters because the radius of the circle is 6 centimeters. What's the measure of segment BC? We know that's 3.2 centimeters. So I just subtract those and I get that the measure of segment CK in here is 2.8 centimeters. Part B, we want to find the measure of segment AB. So where's segment AB? That would be this segment right here. So it's a little bit more than our radius here. So how do we find the measure of segment AB? Well, I know the measure of segment AJ is 8 centimeters. So I just have to take the measure of segment AJ and add the measure of segment JB. That will give me the measure of segment AB. But the question is, what is the measure of segment JB? Well, if I know that the radius of circle J is 8 centimeters, then I know that the measure of segment JC over here is also 8 centimeters. So if I want to find the measure of segment JB, I just take 8 centimeters, subtract 3.2 centimeters, and I'm left with 4.8 centimeters. That I can plug in for the measure of segment JB. Now all I have to do is add the measure of segment AJ plus the measure of segment JB, so 8 centimeters plus 4.8 centimeters. That gives you 12.8 centimeters, and you're done.
Bananas good, humans bad. You try.
Okay, doing the same thing, except this time we have three circles, circle L, circle M, and circle P. We want to label our figure first, just like we did before. So this says the diameter of circle L is going to be 10 feet. Well, we're only given a radius of circle L. Well, remember, the radius of a circle is just the diameter divided by 2. So if I divide 10 feet by 2, I get 5 feet. That would be the measure of segment LR, our radius of circle L. This also says that the diameter of circle M is 16 feet. Well, we got a lot going on in here, so I'm not going to label that just yet. We also know that the diameter of circle P is 7 feet. So over here, circle P, we know the diameter is 7 feet. That means that the radius would have to be the diameter divided by 2. So the measure of segment PN, or NP over here, would be 3.5 feet. Now I can get to answering my question. I want to find the measure of segment RP. So where's segment RP? That would be this segment right here. It's made up of 1, 2, 3 little segments. Or you could think about it as being made up of 2 segments, the measure of segment RM and the measure of segment MP. Why do we do it like that? Because segment MP is a radius of circle M. And if we know that circle M has a diameter of 16 feet, that means the radius must be half of that. So the measure of segment MP, we know, must be 8 feet. So what is the measure of segment RM then? Well, again, the diameter of circle M is 16 feet, meaning the radius, the measure of segment LM over here, must be half of that, so 8 feet. And if we know that this measure right here is 5 feet, we know the measure of segment RM must be 8 feet minus 5 feet, which is 3 feet. So I can say the measure of segment RP is going to be 3 feet plus 8 feet, which is going to be equal to 11 feet. Next, we can find the measure of segment LN. So where's segment LN? That would be this segment right here. Well, again, we have a segment made up of 3 different segments. Or we can write it as 2 segments, the measure of segment LM plus the measure of segment MN. And again, we do this because segment LM is a radius of circle M. And because the diameter of circle M is 16 feet, we know the radius must be 8 feet. So if this is 8 feet, we just have to add that to whatever the measure of segment MN is. Well, how do I find the measure of segment MN? It looks like the measure of segment MN is just equal to the measure of segment MP minus the measure of segment NP. And if I know that the radius of circle N we said is 8 feet, and I subtract out 3.5 feet, then all that's left is the measure of segment MN, which is 4.5 feet. So I'm going to take that 8 feet, add it to the 4.5 feet, and I should get the measure of segment LN, which is 12.5 feet. Now, example 3 says find the circumference of each circle. Round answers to the nearest thousandth. Now, if you recall, we had 2 circumference formulas. Circumference of a circle is equal to pi times the diameter, and circumference of a circle is equal to 2 times pi times the radius. Well, in this particular instance, in this example, we are given the measure of the diameter of circle M. Therefore, we're going to use the circumference formula, C is equal to pi times D, where D is the measure of our diameter here, which is 12 inches. So we can plug that in here. Now, if I simplify this, I just get that the circumference of our circle here is 12 pi inches. This is the exact circumference of this circle. But since this question asks us to round answers to the nearest thousandth, what we're going to do is we're going to multiply in our calculator 12 times pi, round that to the nearest thousandth, and we get that the circumference of the circle is approximately equal to 37.699 inches. Part B, doing the exact same thing. Again, we want to find the circumference, and we know 2 circumference formulas. Circumference of a circle is equal to pi times the diameter, or circumference of a circle is equal to 2 times pi times the radius. In this particular example, we are given the measure of a radius. Therefore, we want to use the circumference formula, C is equal to 2 pi r. Now what we're going to do is we're going to take the measure of our radius, 5.7 feet, plug it in here. We can then multiply together the 2 and the 5.7, and we get that the exact circumference of this circle G right here is 11.4 pi feet. But again, this question wants us to round our answer to the nearest thousandth. So in our calculator, we're going to take 11.4, multiply it to pi, and round that to the nearest thousandth, and we get that our circumference of this circle G is approximately equal to 35.814 feet.
Time for you to try, or I'll be a monkey's uncle.
Doing the same thing here. Again, we know 2 different circumference formulas. C is equal to pi d, or C is equal to 2 pi r. In this particular example, we are given the measure of a radius, the measure of segment EG. Therefore, we're going to use the circumference formula. The circumference of a circle is equal to 2 times pi times the radius. C is equal to 2 pi r. Now all we have to do is take the measure of our radius here, 10 rad 3 centimeters, plug it in for r, and then we simplify it. 2 times pi times 10 rad 3, we multiply the 2 pi to the 10 out front of the radical, and we get 20 pi rad 3 centimeters. This would be the exact circumference of circle G up here. But I want to round my answer to the nearest thousandth, which means in my calculator, I'm going to multiply 20 times pi times rad 3 and round that to the nearest thousandth, and I get that the approximate circumference of circle G is 108.828 centimeters. Doing the same thing for part B. We want to find the circumference of this circle over here, and this time we are given the measure of the diameter. So we're going to use the circumference formula. C is equal to pi times d. The circumference of our circle is equal to pi times the diameter. We know the measure of our diameter is 4.9 inches, so we're going to plug that in for d down here, and we have our exact circumference of this circle up here. But this wants us to round our answer to the nearest thousandth. So what we're going to do is multiply 4.9 times pi in our calculator, round that to the nearest thousandth, and we get that the approximate circumference of this circle up here is 15.394 inches. Now, example 4 says find the exact circumference of circle G. So, again, to find the circumference of a circle, we have two formulas we can choose from. Either circumference of our circle is equal to pi times the diameter, or circumference of our circle is equal to 2 times pi times the radius. Well, in this particular example, we're not given the diameter, and we're not given a radius. So what do? Well, we are given a triangle LMN, that is inscribed in circle G, meaning that each of the vertices lie on circle G. We also know that one of the sides of triangle LMN, segment LN here, is a diameter of circle G. Well, when you have a triangle that's inscribed in a circle where one of the sides is a diameter of the circle, we know that this must be a right triangle. So angle M right here would be a right angle. Well, if we have a right triangle and we're given two side lengths, couldn't we figure out the third using the Pythagorean theorem? Yeah, so let's find our diameter here, the measure of segment LN, using the Pythagorean theorem. We can say that the measure of segment LM squared plus the measure of segment MN squared has to equal the measure of our hypotenuse squared, the measure of segment LN squared. Now we can plug in what each of those are equal to. The measure of segment LM is 3 meters, that goes in here. Measure of segment MN is 4 meters, that goes in here. And we're solving for the measure of segment LN. Now we just simplify and solve for the measure of segment LN. 3 squared is 9, 4 squared is 16. Add those together, you get 25. To get LN by itself, we square root both sides, and we get that the measure of segment LN is equal to plus or minus 5. Now, in this particular instance, we can't have a negative diameter, so we're just going to say that the measure of segment LN is equal to 5 meters, so we can label that here. Now, did we answer the question? No, it wants us to find the exact circumference of circle G here. Well, remember, the circumference of a circle formula, we have two of them. C is equal to pi times d, the circumference of a circle is equal to pi times the diameter, or circumference of a circle is equal to 2 times pi times the radius. C is equal to 2 pi r. Well, in this particular example, we just found the diameter, so we're going to say C is equal to pi times d. So we're going to use C is equal to pi times d, where d is the diameter. So we're going to take our diameter that we found, 5 meters, plug it in here, and then we simplify it. 5 times pi, we're just going to leave as 5 pi meters because it wants the exact circumference. When it wants you to find the exact circumference, you're going to leave your answer in terms of pi, meaning you're going to leave pi in your answer.
Yes, right.
Okay, doing the same thing here, we want to find the exact circumference of circle G over here. But we aren't given an inscribed triangle like we were last time. We're given a quadrilateral that's inscribed in this circle. Well, what do? Well, what I could do is I could get two separate inscribed triangles if I were to draw a line segment connecting points R and T that passes through point G. That would create two separate triangles here, and because each of these triangles would be inscribed triangles where one side length is going to be a diameter of this given circle, that means each of these triangles would have to be right triangles. Now remember, I'm trying to find the circumference of this circle, and the circumference formula is C is equal to pi times d, where d is the diameter, so I need to find the diameter here. Again, I've created a right triangle here where I know two of the legs of the right triangle, the measure of segment PT over here and the measure of segment PR over here. I'm trying to find the length of the hypotenuse, the measure of segment RT. So I use the Pythagorean theorem. PT squared plus PR squared is equal to RT squared. Now all I do is plug in what I know. I know the measure of segment PT is 5 centimeters, that goes in there. Measure of segment PR is 12 centimeters, that goes in there. Now I simplify and solve for the measure of segment RT. 5 squared is going to be 25, 12 squared is going to be 144. I then add those together and I get 169. Now to get the measure of segment RT, I have to square root both sides to get rid of this square. The square and the square root cancel each other out. I get the measure of segment RT is equal to plus or minus 13. But the only issue is I'm dealing with the diameter of this circle. There's no way that can be negative. So I'm just going to take the positive version, our principal root, and say that the measure of segment RT is equal to 13 centimeters. So I can now label that over here. But that's not what I'm trying to find. I'm trying to find the exact circumference of circle G. So I can use this now to find the circumference of the circle. Remember, the circumference of a circle formula, there's two. C is equal to pi times d, and C is equal to 2 pi r. In this particular instance, because we found the measure of our diameter, we're going to use C is equal to pi times d, where I plug in 13 centimeters for d, and take 13, multiply it by pi, and now I have the exact circumference circumference of circle G. Remember, your exact circumference has to be in terms of pi, meaning pi needs to be in your answer. Now, example 5 says find the exact circumference of circle K. So we're doing the exact same thing. We have a triangle that is inscribed in a circle where one of the sides is a diameter of this circle, meaning that this triangle, triangle ABD, must be a right triangle. We also know that one of the acute angle measures of this right triangle is 45 degrees. So if I take 180 degrees, subtract 45, and subtract 90, I'm left with 45 degrees, meaning I have created a 45, 45, 90 degree triangle. Now, how is that going to help us find our diameter here? We need the diameter in order to figure out our circumference. Well, in a 45, 45, 90 degree triangle, we know a couple things. We know that the lengths of the legs are congruent, meaning that the measure of segment AB has to be equal to the measure of segment BD. So both of these segments are 7 feet. We also know that the hypotenuse of a 45, 45, 90 degree triangle is equal to rad 2 times one of the legs. So the measure of our diameter here, the measure of segment AD, is going to be equal to rad 2 times the length of our leg over here, which is 7 feet. So 7 times rad 2 gives you 7 rad 2 feet. That's going to be the length of our diameter. We can now find the circumference using the formula C is equal to pi times D, where D is our diameter. So we take 7 rad 2 feet that we found our diameter to be, plug it in for D. We multiply 7 times pi times rad 2. We get 7 pi rad 2 feet. And since it wants us to find the exact circumference, we leave this as our answer in terms of pi.
Pretty soon, I'm going to see you at the zoo. You try.
Okay, doing the same thing, we again have a circle where a triangle is inscribed in the circle, meaning each of the vertices are on the circle, and one of the sides of that triangle is a diameter of this circle, meaning that this triangle, triangle EFG, has to be a right triangle. We also know that one of the acute angle measures is 60 degrees. So if I want to find the other acute angle measure, I just take 180, subtract 60, subtract 90, and I'm left with 30 degrees, meaning I've created a 30, 60, 90 degree triangle over here. Now that should come in handy in answering this question. What are we trying to find? We're trying to find the exact circumference. And we know two circumference formulas. C is equal to pi times D, where D is the diameter, and C is equal to 2 pi r, where r is the radius. So in this case, we need to find our diameter here in order to calculate our circumference. So how do we find the diameter? Well, this is where our knowledge of a 30, 60, 90 degree triangle comes in handy. In a 30, 60, 90 degree triangle, everything is based on the short leg, the side opposite the 30 degree angle. The short leg times 2 will give you the hypotenuse, the side opposite the 90 degree angle, and the short leg times rad 3 will give you the length of the longer leg, the side opposite the 60 degree angle. Well, we're only given the length of the longer leg, the side opposite the 60 degree angle. That's 6 feet. So we need to use that in order to find the length of our shorter leg, because then we can take that measure, multiply it by 2, and that will give us our diameter. So how do we find the length of our short leg? Well, again, the short leg times rad 3 will get you the length of the longer leg, meaning the length of the longer leg divided by rad 3 should get you the length of the shorter leg. So 6 divided by rad 3 will give you the length of our shorter leg in this 30, 69 degree triangle. Well, what is 6 divided by rad 3? Well, we can't divide that. So what we're going to do is we're going to rationalize this fraction by multiplying the numerator and denominator by the radical that is in the denominator. 6 times rad 3 is going to be 6 rad 3. Rad 3 times rad 3 is going to be rad 9, which is 3. Now we can divide the 6 and the 3 and we get 2 rad 3 feet. That's going to be the measure of our short leg, but that is not our diameter. Remember, the diameter in a 30, 69 degree triangle is equal to 2 times the length of our shorter leg. So what is 2 times 2 rad 3? Well, we just multiply the 2 and the 2 out front and we get 4 rad 3 feet. That's going to be the measure of segment EF, our diameter over here. Now we can use that measure in order to find the circumference of this circle. Remember, the circumference of a circle is equal to pi times D, or 2 pi r. In this case, since we found the diameter, we're going to use the one with D in it. So all we have to do now is take 4 rad 3 feet, plug it in for our diameter over here, and then we multiply the pi times the 4, and then multiply that by rad 3. We get 4 pi rad 3 feet as the exact circumference of circle K. We know it's exact because we left the pi in it. Now, word problem says if a bicycle travels 5 feet in 1 revolution of its tires, find the radius of the tires. Round answer to the nearest hundredth of an inch. So let's see what this looks like. This girl is going to start at a starting point. So we're going to put a little tick mark on the tire. And then it's going to rotate around 1 revolution until it gets right back to that same exact spot. And that distance that she has traveled is 5 feet. Now, the cool thing about this is that this is saying the bicycle traveled 5 feet in 1 revolution of the tire, meaning 1 revolution revolution of this tire is 5 feet, meaning the perimeter of this tire is 5 feet, meaning the circumference of this tire is 5 feet. So if this question wants us to find the radius of this tire, what we're going to do is we're going to set up an equation involving the circumference and the radius. So is there an equation or formula that we know that involves circumference and radius? Yeah, the circumference of a circle is equal to 2 times pi times the radius, or c is equal to 2 pi r. Now I can take what I know and plug it in. I know that the circumference of this tire is going to be equal to 5 feet. So I can take 5 feet, plug it in for c over here, and now I can solve for the radius of this tire. So how do I do that? I get r by itself by dividing both sides of this equation by 2 pi. Over here, the 2 and the pi cancel each other out. On this side, we're just going to leave it as 5 over 2 pi feet. Now, why do we do that? Because if you look at the question, it wants us to round our answer to the nearest hundredth of an inch. Well, we got our answer in terms of feet. So how do we convert from feet to inches? Well, you take the number of feet and you multiply it by 12. So we take 5 over 2 pi feet, and that'll give us our radius in terms of inches. Now, because we are rounding our answer to the nearest hundredth of an inch, we don't want to leave pi in our answer. We're just going to plug all of this in our calculator and round it to 2 decimal places. And we get that our radius of our tire is approximately equal to 9.55 inches.